Welcome all my dear students to Sudharma's Physics classroom. Today we are going to discuss CBSE Science Board Paper 2019 Physics Questions and Answers. So let's get into the questions. Write the function of voltmeter in an electric circuit. So as we know, the function of a voltmeter is to measure the potential difference across any appliance or any circuit element. So the function of the voltmeter in a circuit is to measure the voltage dropped across any appliance, and the voltmeter is always connected in parallel to the circuit. What is a rainbow? Draw a label diagram to show the formation of a rainbow. So rainbow is a natural spectrum, right? When white light enters to the water droplets in the atmosphere, it splits. So these small water droplets act like a prism, and the 7 colors of the white light will be splitting, and when then we come get to see the rainbow. So rainbow is a natural phenomenon in which white light splits into beautiful colors by water droplets which remain suspended in air after the rain. Formation of the rainbow diagram has to be drawn here because the question specifically asked for the diagram. Okay, so another question we can expect here as an additional point we can expect is what are the phenomena taking place during the formation of a rainbow? We know that it splits once it enters into the water droplets, it splits into its 7 colors. That means dispersion happens, and when those colors try to come out of this water droplet to air, then internal reflection takes place, then refraction takes place. So these are the phenomena taking place during the formation of a rainbow. Next question is a long answer question. With the help of a suitable circuit diagram, prove that the reciprocal of the equivalent resistance of a group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistances. So how do we prove that? So for that we need a diagram, a circuit diagram as shown in figure. So you have to draw the diagram where we have n number of resistors connected in parallel, and it is connected to a cell, and the direction of current is from the positive to negative end. And we know that when the resistors are connected in parallel, the voltage, the potential difference across all the resistors will be the same, and the current will be splitting, right? So when we have a lot of resistors connected in parallel, the total current I will be equal to I1 plus I2 plus etc. plus IN. There are n number of resistors. And from Ohm's law, we have I is equal to V divided by R. So here, since this R is representing the parallel combination of resistors, I'm going to put it as RP. So this is equal to V divided by R1 plus V divided by R2 plus etc. plus V divided by Rn. Since in a parallel combination of resistors, the potential difference is the same, this term V from both the sides cancels. So we will be getting 1 by Rp is equal to 1 by R1 plus 1 by R2 plus etc. plus 1 by Rn. So this is what is asked to prove here. Because the equivalent resistance, the reciprocal of the equivalent resistance of a group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistances. Now question B. In an electric circuit, two resistors of 12 ohm each are joined in parallel to a 6-volt battery. Find the current drawn from the battery. So how do you do that? So R1 and R2, they are equal to, both are equal to 12 ohms. So 12 ohm, and it is connected to a 6-volt battery. So from our formula, we know that 1 by Rp is equal to 1 by R1 plus 1 by R2. We have only two resistors and they are with equal resistors. So this is 1 by 12 plus 1 by 12. That's going to be 2 by 12, or it's equal to 1 by 6. Or this is 1 by Rp. So parallel combination of resistor Rp is equal to 6 ohm. So question is to calculate the current drawn from the battery. So current I is equal to V divided by R from Ohm's law. So here R represents the equivalent resistance of the parallel combination, and V is equal to 6 volt. V is equal to 6 volt. So V is equal to 6 divided by RP. RP is 6. So this is going to be 1 ampere. So the current is 1 ampere in the circuit. The next question. An electric lamp of resistance 20 ohm and a conductor of resistance 4 ohm are connected to a 6 volt battery as shown in the circuit. Calculate the total resistance of the circuit, the current through the circuit, the potential difference across the electric lamp and the conductor, and power of the lamp. So the resistance is given. Resistance of the lamp is 20 ohm. So as seen in the figure, we can say that they are connected in series. So this figure is it's a part of the question. So the lamp and the resistor, they are connected in series. So the first answer is going to be R series is equal to, R series is R1 plus R2. So here it is the resistance of this resistor plus the resistance of the lamp. So that is going to be 4 plus 20. So that is nothing but 24 ohms. Question B. Current through the circuit. Current I is equal to V divided by R series. V is 6 volt. R series is 24. So this is 1 by 4 or 0.25 amperes. The potential difference across the electric lamp. Potential difference across the electric lamp V is equal to IR. I is 0.25 and resistance of the lamp is 20. So this is how we calculate the voltage or the potential difference. So I into R, the total current in the circuit multiplied by the resistance. So we will get 5 volt. And question C, part 2. Don't miss any of this. So question 2. So it's the potential difference across the conductor. That means the current flowing through the conductor multiplied by resistance of the conductor. So current flowing is 0.25. It is the same series connection. And resistance of the conductor is 4. So we are going to get 1 volt. Now question D. Power of the lamp. Power we can calculate using any method because we have I we calculated, V is there, and R is also there. So I'm going to use the simplest formula, that is VI. So V means the potential difference across the lamp. Okay, so potential difference across the lamp was 5 volt. So 5 into 0.25, that is equal to 1.25 watts because power is expressed in watts. Next question. Draw magnetic field lines produced around a current carrying straight conductor passing through cardboard. Name, state and apply the rule to mark the direction of these field lines. How will the strength of the magnetic field change when the point where the magnetic field is to be determined is moved away from the straight wire carrying constant current? Justify your answer. So question A, draw magnetic field lines produced around a current carrying straight conductor. So we know that when current flows through a straight conductor, we are going to get concentric magnetic fields, right? Concentric circular magnetic field. And nearby the conductor, the concentration of the field lines is going to be more. Name, state and apply the rule. So names, this is a long answer question. Name, state and apply the rule to mark the direction of these field lines. So we are going to use right hand thumb rule, right? So right hand thumb rule we have to use. So that is a rule to find out the direction of magnetic field. And the statement is keep your right hand thumb in the direction of current and wrap around the conductor with the other fingers. So the direction in which the other fingers wrap around the conductor will give you the direction of magnetic field. So as shown in the figure, even you need to be very careful when you draw the diagram. So make sure you are drawing the diagram from positive, the direction of current you are marking from positive to negative. So accordingly, you're going to mark the direction of magnetic field. So as per this diagram, the current is going downward. So you're going to keep the thumb downward. Then we will be getting a clockwise magnetic field. Second question, how will the strength of the magnetic field change when the point where magnetic field is to be determined is moved away from the straight wire carrying constant current? Justify your answer. So we will be using a compass needle to find out the magnetic field strength to plot the magnetic field lines. So if you move the point away from the magnetic field, or if you are keep going to measure the magnetic field strength at a point little bit far away from the current carrying conductor, then we know that nearby the conductor the strength of the magnetic field is going to be more. When we go away from the conductor, the strength is going to be less. So we can see when we do this experiment with the compass needle, you can see that the deflection will be less. If you go away from the conductor, then the deflection will be less, and we can say that the strength is less at that position. Next question. An object is placed at a distance of 60 centimeter from a concave lens of focal length 30 centimeter. Use lens formula to find the distance of the image from the lens. List 4 characteristics of the image: nature, position, size, erect or inverted, formed by the lens in this case. Draw a ray diagram to justify your answer of part 2. So we have a concave lens, so keep that in mind and apply the sign conventions. Object distance is always negative. Focal length, it is a concave lens, so focal length is negative. So we have to find out image distance. So our formula is 1 by f is equal to 1 by v minus 1 by u. So substitute it with the proper sign. Always remember object distance is negative. Concave lens focal length is negative. So when we calculate, you can see that we are getting the image distance as negative. So when the image distance is negative in the case of a lens, the image is on the left hand side, or it is at the same side of the object. So in the case of a lens, if the image distance is coming as negative, then it is a virtual image. We have to, because we have to state the characteristics, list the characteristics of the image. When the image distance is negative, it is going to be a virtual. All the virtual images are inverted. I mean, it is erect, it is upright. So it's erect. All the real images are inverted. So here it is a concave lens, and concave lens never ever forms a real image. Concave lens always forms a virtual image. So we don't have to think twice. The concave lens produces erect image. Erect image, and it is diminished. Diminished. Okay. So nature is, it is virtual. Position is, it will be as per the geometry, it will be formed between the optical center and the focus. Image will be formed there. And we have to say the size, it is diminished or it is smaller. Then erect or inverted, it is erect. Okay. Now draw a ray diagram to justify your answer of part 2. So we are going to draw the ray diagram for concave lens. That's it. We don't have to worry too much about that. We just have to draw a ray diagram for concave lens. Then, next question. While studying the dependence of potential difference across a resistor on a current passing through it, in order to determine the resistance of the resistor, a student took 5 readings for different values of current and plotted a graph between V and I. Between V and I, he got a straight line graph passing through the origin. What does a straight line signify? Write the method of determining the resistance of resistor using this lamp. So, here the straight line says that voltage is proportional to current. They are in direct proportionality. That means when one quantity increases, the other quantity will be increasing. That's the meaning of directly proportional. Okay, so write the method of determining the resistance of the resistance of the resistor using this graph. So we know that a VI graph, see, look at this graph. This is given in the question. So voltage and current are given. Current is in the y-axis and voltage is in the x-axis. So if you take the slope, so when we are taking the slope of this graph, that is equal to I by V. That's nothing but reciprocal of resistance. So you have to take, if you have to calculate the resistance, take reciprocal of the slope. So we know that the slope of a VI graph will give you the resistance. But look at the data given on this particular graph given in the question. B is along x-axis and I is along y-axis. That is why we have to take the reciprocal of the slope. So whenever this kind of a graph comes in the exam, be very careful. Look at the values given on x and y-axis. Okay. Because slope is always y divided by x, y coordinate divided by x coordinate, right? That is how we take slope. So here, when we take that, it is going to be I by v. So to take the resistance, take the reciprocal of the slope. And the last question, what would you suggest to a student if while performing an experiment, he finds that the pointer needle of the ammeter and voltmeter do not coincide with the 0 marks on the scale when the circuit is open? No extra ammeter, voltmeter is available in the laboratory. So this particular question, it's a zero error of the scale of the ammeter or voltmeter. It's like, see, normally if it is not coinciding with the zero, then we will have to, depending on how many measurements it is, this needle is coinciding, we have to reduce that amount from the actual reading. Okay, so if there is a zero error, because it is not coinciding with a zero, so that is why it is called a zero error. If there is a zero error, then this error is subtracted from the value that depicts when the circuit is closed. So for example, if my needle is starting from here, say this is the zero of the ammeter, say this is ammeter, 0, 1, 2, 3, 4, 5, and 6. So, if the needle initially, before starting the experiment, if the needle was here, and now after the circuit is closed, my needle goes here. So, we cannot read the value as 4. Okay, so we have to subtract 4 ampere minus 1 ampere, because if it started from 0, okay, we can directly read the reading as 4 amperes. But our meter or voltmeter in the question, it is not coinciding with the 0 mark. So we will have to subtract. So for minus 1, so it's going to be 3 ampere in this diagram. So we don't have to draw a diagram. I'm just explaining for your understanding. Okay. So accurate value, if we need, then we have to make sure it starts from 0. In all the devices, in many devices, we can see it is not coinciding with 0. Then we can do the error calculation. That means subtract that value wherever it was initially before the beginning of the experiment. That value you have to subtract from the actual reading, so that you will be getting the correct value. Okay. So this is all about 2019 question paper. So you can see it is very, very easy question paper. So all of you can score full marks from the board exam if you concentrate on these types of questions and the pattern of questions. Okay. So next class I'll be coming with CBSE 2018 board question paper, physics questions. So if you are first time to the channel, please subscribe to the channel and click the bell icon for more updates. I'll be coming very soon with 2018 board paper solution. Thank you for watching.